Hello. So today we are starting with signal propagation. Now, as everyone know, propagation means to travel. So as light needs a medium to travel, similarly any signals, radioactive signals or radio signals, radiations also need a medium to travel. So in wireless network, we cannot determine like what path the signal will choose as in wired networks, because in wired network it is a dedicated channel, physically connected channel, so the signals have an idea to move across the wire. So if a wire is within the straight line, it will still move across that straight line. If the wire is in a circular channel, it will move across the circular channel. But as in the case of wireless network, the behavior is unpredictable. You can only predict the behavior of radio signals in wireless in case of vacuums. That's it. So while propagating from one place to another, we have different possible transmission ranges. Uh, First is transmission range. Transmission range is a range where the signals are very clear cut. Communication is possible. There is no disturbances available and there is no error rate or say error bit added to the actual signal. Next is the detection range. Detection range is where you detect that a signal is coming, that a radio signal is active, but the communication is not possible, maybe because it is not able to reach fully, or maybe because it is not that clearer as in the transmission range. And the last range is interference range. The name itself suggests interference in the sense there may be possible that two frequencies mix up. So because of these lot of interference, it is not possible to detect a signal. So in this region, the signals may not be detected, as well as the interference may be added, like this noise, background noise, or any error bits can be added. So there are high chances of signals getting lost or say signals getting weak in this range. So these are the three possible ranges when signal propagation takes place. Next, we study path loss of radio signals. Now, as we know, whenever any signal, be it a light signal or a sound signal or a radio signal, when it travels from one place to another, there may be a chance where that signal is getting lost. Why it is getting lost? Maybe because of its wavelength, maybe because of its strength. So if you have been knowing idea about amplifiers, why we use amplifiers? Because जब वो एक जगह से दूसरी जगह travel करता है, सिग्नल का स्ट्रेंथ कम होने का चांसेस होता है. So by amplifying a signal, what we are doing is we are increasing its strength so that it can travel more longer distances. Similarly, for radio signals, it is applicable. So the reasons why the radio signals can be lost is again because it might be weakening while traveling the distances. In free spaces, radio signals propagate as light does. That is, they follow a straight line. So as I said, in vacuum, in space, radio signals also follow the rule which the light signals follow. That is to flow or say to propagate in a straight line. So in space or in vacuum, radio signals travel in a straight line. If such a straight line exists between a sender and a receiver, it is called as line of sight. So अगर ऐसा कोई भी एक straight line यानी space available है और एक sender से दूसरे sender यानी एक sender से हम receiver पे signals भेज रहे हैं in space, and there is a direct line or say straight line which is available between sender and receiver, that straight line is called as line of sight. Even if no matter exists between the sender and receiver, the signal still experiences free space loss. We say even if it is a vacuum, see vacuum नहीं होता तो air particles होता है, water है तो water particles होता है, gaseous particles होता है. So these material mediums somewhere tend to make a loss of the signals which have been transmitted. But even if there is a vacuum, there is still no guarantee that 100% the signals will be transmitted correctly from sender to receiver. The received power P1 is proportional to 1 upon d square, with d being the distance between the sender and receiver. That is what we call as inverse square law. कि जो भी हमने signal भेजा है with this power is proportional to d 1 upon d square. यानी it is inversely proportional. Inversely in the sense जितना ज्यादा distance होगा उतना weakening the signal will become. जितना कम distance है, the signal might be strong enough to travel that short distance. So the strength or say wavelength of the signal on the receiver end depends upon the distance between sender and receiver. Even without any matter between sender and receiver, additional parameters are also important, which might be the reasons for the loss of radio signals in space. So they are The received power also depends on the wavelength and the gain of receiver and transmitter antennas. As I said कि जो भी हम signals भेज रहे हैं वो receiver के wavelength उसके area पे depend करता है, like what is the distance between sender and receiver, and also the antennas they have been using कि वो antenna के पास कितना strength है कि वो received signals को detect करके उसको बिना loss के कितना वो ले सकता है. So उसके एडिशनल साइड इफेक्ट्स या एडिशनल सिग्नल प्रोपोगेशन इफेक्ट्स कौन से हैं, यानी what are the other factors because of which the signals become weak or their strength loses? That is what we are going to see. So first is reflection. Reflection of a light in everyday occurrences, mirrors are commonplace and can be seen in houses and many other places. So as we know, हमने reflection of light तो पढ़ा है. Mirror is the first and foremost example for reflection of light कि जो भी rays है वो किसी भी reflecting surface पे hit होता है, वो hit होके वापस travels in the same medium, because of which we are able to see objects very clearly. Similarly, radio waves are reflected with many surfaces. It is not only light reflections, but also radio wave signals are reflected many times because of some reflecting surfaces. When a radio wave is traveling between huge buildings or mountains, the signals is reflected due to the surface of the structure. यानी अगर ये बिल्डिंग का स्ट्रक्चर है, माउंटेन्स के बीच में अगर कोई रेडियो वेव सिग्नल्स प्रोपोगेट हो रहा है, देन बिकॉज ऑफ देयर स्ट्रक्चर इट माइट हैपन दैट द सिग्नल व्हिच इज ट्रैवलिंग ओवर हियर हैज हिट दिस बिल्डिंग एंड इट हैज बीन रिफ्लेक्टेड, यानी वो टकरा के वापस आया है. But the reflected signal is not as strong as the original signal, as the object can absorb some of the signal's power. Most often the signal is reflected, the weaker it becomes. जैसे हमने देखा that assume that the signal is traveling over here and it has hit this building, so it will hit and it will come back. So this hitting and this is reflecting. So जो reflected signals होता है, it is not as strong as the signal propagated originally. Why? Because whenever you are hitting the surface, the object you are hitting on may occupy some of its strength, may occupy some of its power. So because of it, the reflected signal will lose some of its strength and it will not be as strong as the original one. The more it is reflected, यानी वो जितना ज्यादा टकराएगा उतना ज्यादा वो weak होते जाएगा, उतना receiver के end पे पहुंचने में problems होगा. So the first effect is reflection, because of which the signal gets weak. Next is scattering. Scattering is the loss of signal caused by diffusion of a signal. Now, everyone know what is scattering. Scattering of light हमने पढ़ा. Scattering of light is spreading out light in different directions. जैसा बहुत सारा material mediums होता है which scatter light signals. The one which scatters light signal will also have the ability to scatter radio signals as well. Scattering typically helps when a radio signal hits an impurity environment. Dust, humidity, unevenness, and other qualities in a material can cause a signal to scatter in all directions. जैसा मैंने बोला कि अगर वो signal air में travel कर रहा है तो dust होता है, humidity होता है. So all this material medium, what do they do? Whenever the signals hit them, they just spread it in all directions. So when you're spreading it, again the signal ka strength becomes weak because it is distributed in different directions, because the original power is cut into half. So it is impossible to retrieve the original signals with the same power. This can have significant impact on the signal integrity and strength. An incoming signal is scattered into several weaker outgoing signals. जैसा मैंने बोला था कि ये एक incoming signal है, लेकिन अगर ये कोई material medium पे hit हुआ, which is having the ability to scatter the signals across it, तो ये जो radio signal जो एक original आ रहा था, जो बहुत strengthened है, बहुत power के साथ आ रहा है, so it is hitting it, and when it is being dispersed or वैसे when it is being scattered, if you see ये एक signal को तीन में divide करके हमने भेजा है, तो इसका power भी divide हो जाता है. And because the power is divided, the signal becomes weak. So the second reason for signal weakening is scattering. Next is signal propagation, so diffraction. Now, diffraction is very much similar to scattering. Radio waves still will be deflected by an edge and propagate in different directions. Now scattering and diffraction are one and the same thing. The only difference with scattering was कि वो medium के through hit होके वापस scatter होता है, whereas diffraction में क्या होता है कि अगर कोई ऐसा edge आता है pointed, okay, तो वो edge को hit करने की वजह से the signals are getting divided. So again it is basically leading